Assalamu alaikum everyone. This is Muaj with you today, and we will be discussing two topics. The first one is marginal rate of substitution, and the second one is consumer's equilibrium. So, yeah, both of them are two very important topics in economics. If we look at the marginal rate of substitution, also known as MRS, we have the definition. The marginal rate of substitution actually refers to the rate. It is the rate at which a consumer is willing to give up one good in exchange for another while keeping their overall satisfaction constant. What does it measure? It measures the slope of an indifference curve. Perhaps you know about indifference curve. If you don't, I will put a link in the comment. And it reflects how a consumer balances goods to maintain the same satisfaction. We have the formula MRS of product X and Y is the change of product X divided by the change of product Y. What does MRS means in real life? What does it actually means? Why is it important to economics? We'll know in the next slide. We have the characteristics of MRS. The first one is diminishing MRS. It means as a consumer substitute one good for another, they are willing to give up less and less of the second good. This reflects the convex shape of the indifference curve. Actually, what does that mean? If we when we will see the table and the graph, we'll know. The second one is subject to trade-off, which means MRS varies from people or person to person based on their preference, their taste, and their consumption habits. The next characteristic is the slope of the indifference curve. What, as we have already mentioned in the earlier slide, that the MRS is actually the slope of the indifference curve, IC curve. MRS is represented by the slope of the curve, which changes along the curve due to diminishing marginal utility. The steeper the slope, the higher the MRS. The flatter the slope, the lower the MRS. I mean, it is actually hidden in the indifference curve. When you look at the indifference curve, you are actually seeing the MRS, but you can't realize. But if you are mathematically analyzing, you will see. Here we have the data schedule. We have a table and a graph. On the left hand side, we as the table is showing, we have a different combination, perhaps five ABCDE combination of two products, product A and product B. In the combination 1 or combination A, we consume a consumer is consuming product A 1 unit and product B and 10 unit, and here the MRS is 0. On the combination B, a consumer is consuming product A little more, perhaps 1 unit more, a total of 2 units, but the consumption of product B is lessened now. It has become 5. If we analyze the data, we'll see the MRS is 5 on combination B. Why does it become 5? Actually, when you are seeing that a consumer is getting 1 more unit of product A, he is giving up 5 units of product B. So the MRS is 5. Why does that? Why does a consumer have to give up 1 more unit of product B? Because they have to keep the same satisfaction level. As we have seen in the indifference curve, a consumer has to maintain same level of satisfaction. So he cannot increase his consumption as by his will. If he wants to create a same level of satisfaction all along the curve, he has to go with the combinations. And in combination C, we can see product A is 3, product B is 3. It has lessened. Again, product A increases, product B decreases, meaning the MRS is 2 right here. And in all the combinations, there is same level of utility. And the data schedule on the left hand side, the table is represented in the graph. On the right hand side, we have the product A along the x-axis, product Y along the y-axis. If we see the combination, then we will see actually it is an indifference curve, but the slope there represents the MRSs, and MRS is decreasing as we have seen from the combinations. product B, combination B, C, D, E, MRS is continuously decreasing, and this is for the diminishing MRS. And today our next topic is consumer's equilibrium. We'll see a mathematical and graphical analysis. What is a consumer's equilibrium actually? Consumer's equilibrium is the situation in which a consumer allocates their limited income. It is very important in economics that we cannot go out of our income. A consumer allocates their limited income in such a way that they achieve the maximum possible satisfaction given the prices of the goods and their budget constraint actually. Right hand side, it will be a lot easier if we see in the graph. On the right hand side we have the graph along the x-axis. We have two axes, x and y axis. Along the x-axis we have quantity of commodity x. Along the y-axis we have quantity of commodity y, and we have many indifference curves here: IC1, IC2, IC3, IC4, which along the ICs the total level of satisfaction is the same, as you know. And the red line here is actually the budget line, or the budget curve, or the budget constraint. If we look at the graph, so in it, if we look at the graph, we will see that the budget line intersects the indifference curves in 3 points, actually in point M, point E, and point N. All of these points can be consumers equilibrium, but why are we picking point E as the consumers equilibrium? Because at this point the slope of the budget line is equal to the slope of the indifference curve. What does it mean actually? It means that it is tangential. The budget line is tangential to the indifference curve in this particular point. On the other points, point M and point N, the slopes actually are not equal. We can say that a different way, that on point the point E resides in the higher IC. It is in the IC2. The higher the indifference curve, the higher the utility. So a consumer will obviously want more utility, so he will go with the point E. And if we see the coordinates of E, we have x star and y star. The x and y star actually represents the consumer's equilibrium point. The point E is actually the consumer's equilibrium point. On the next slide we will see the math. We'll see why we are studying consumer's equilibrium. Actually, the consumer at the equilibrium point, the consumer reaches the highest possible utility given their income and prices, which means they're really willing to go with the higher indifference curve, as we have seen in the graph. At the equilibrium point, the consumer has no desire to alter the consumption pattern, which means they are satisfied. They're very satisfied with the what pattern or what combinations they're having at that point, x star 1 y star. And from the graph we have seen the marginal rate of substitution equals to the ratio of prices of two goods. We will look at that. At equilibrium point, the consumer spends their entire income. In that point there is no surplus or no deficit. At the equilibrium point, the consumer behaves actually logically. They aim to maximize their utility. They tend to get higher and higher in the utility as they try to move higher to the indifference curve. Now we will look to the mathematical analysis of consumer's equilibrium. Actually, I will want to mention two specific points for that. The first point is that at the equilibrium point, the budget line is tangential to the indifference curve. It means that the slope of the indifference curve, or IC curve, and the budget line, the slope of the budget line is same. On the right hand side, we are doing that thing. Particularly, we are calculating the slope of the indifference curve, and then we are calculating the slope of budget line. The slope of indifference curve is actually the MRS XY, as we have known from the MRS, marginal rate of substitution. The product x and y is equal to minus MUS divided by MUY. On the slope of budget line equals to minus P of x divided by P of y. Why is there minus? Because the graph is going down, obviously. And from the points we know that the slope of the indifference curve and the slope of the budget line are equal at the equilibrium point. So for the equilibrium point, we have them as an equation. Both of the minuses are cancelled, and we can see mu(x) divided by p of x, mu(y) divided by p of y. The more we have product, the more we can continue the chain, and so we are taking lambda as a constant. So that is all for today. Thank you for being with me all along the video.